Okay, start recording. So here we are. We're in lecture for Design 300. It's Thursday, November 5th. The recording is on. We're going to be going over 7.2 mostly. However, on Sunday, we do have a portfolio check, which is a pre-check. Okay, it's a pre-check for 7.1 and 7.2. So let me ask really quickly if anybody has a question about 7.1. Any questions on 7.1 out of either Discord or Google Meet? Okay, looks like we're pretty clear on that then. 7.1 is actually really cool. Lots of cool things to think about. Eric, which topic did you end up checking on, or are you going to? Have you made a decision yet?
Yes, actually, I was doing the one that you said that a lot of landscapers. I have to go through my notes really quick.
Yeah, MIG.
Yes, thank you. Yeah,
okay.
I'm taking your advice. If you give it, I'll take it.
that sounds pretty cool. Okay, good stuff. Okay, and I need to, hold on a sec, I have one too many microphones on. There we go. Turned off one of the microphones on my recording. Okay, so that looks really good. Hi, Ayub, over on the Discord side. So let's take a look then and see what we've got for 7.2. Now, 7.2 is not so much about a process. It's about researching certain specific topics that have to do with structural steel and material sourcing. And because material sourcing is very important, but so are qualifications of the welders, you're going to see that even though we're talking about material sourcing, we're also really talking about how is the workforce trained and how do we ensure that the weld got done right. We're calling that part of material resourcing. One reason for that is if you order a large beam or channel or special structural steel shape from a weld shop, with that piece of steel, whether it be an I-beam or a C-channel or some special shape, you will get a certification along with it that the material is correct, that the welders were certified, that the processes follow AWS, and that there was some testing done on the weld if it has been called out. So it's really, by the time the stuff gets to the site, the material that you get has been through many steps that have these aspects. Gale Manufacturing is and was one of the largest steel fabricators on the West Coast, and believe it or not, they have it's almost shut down now, a factory in Woodland. They still have their design and a lot of their facility, their engineering facility, is in Woodland and West Sacramento, but they moved their main plant to Boise, Idaho, because they saw so much of their work going into that area. It was going into Colorado and Montana and Idaho and Oregon and Washington, that they felt that they needed their plant to be located in a better spot. But their plant is really phenomenal. And even their one in Woodland, it is an incredible plant. So if you ever get a chance, of course, they do big, huge stuff. They don't do little stuff, big stuff. So all of this is part of material sourcing. Okay. What does it mean to get A36 material? And how is that controlled so that you know that you're getting A36 material? Because that's the key to structural, is that the properties of A36 are very, very well known. Now, it's not the strongest steel. It's not the most ductile steel. It's not a corrosion resistant steel. But it has properties that are extremely, extremely stable and standard and well known, so that if you're designing with it, you can be sure that what is it? Safety, safety, safety. You can be sure that your safety is assured because there is so much data about it and there's so much known. And when you do a stress analysis, you know that those numbers are right. And when you do a deflection analysis, you know that those numbers are right. So that's why we want to look at A36 as a material, find out that yes, the material is well standardized and controlled, so that if you get A36, you're getting the right stuff. And we'll look at the document that tells us about that a little bit. It's actually about a huge document, but we're going to look at a few pages of it. After that, we have to make sure that the workforce is well trained. So I broke in to the engineering field right out of college with a company that made portable pipe welders. So for 5 or 6 years, welding was my life. And I found out, and I knew nothing about welding before, and boy, do I know a lot now. But I learned that the workforce is the key. And we could weld prep and we could do all sorts of things, but if the workforce laid down a crummy weld, what we called a gorilla weld, your part would not work, no matter how much work we did on the prep side and everything. So a well-trained workforce is key. And so Eric says, a money saver knowing how to weld yourself. So yes, it is at a certain point. So to become certified and to do a good weld that is guaranteed to be safe takes a lot of equipment, a lot of training, and you may or may not make money off of it on your own jobs if that's just part of it. As a landscaper, absolutely for sure, because the safety requirements for most welds, an awning, well, they're usually way over designed. They're not loaded in such a way that the failure would be what's called catastrophic. It could break, but it won't hurt somebody when it breaks. A bench or an iron gate that rusts because you did a lousy weld, you see it long, long, long before. So yes, many, many people in the trades do learn good basic welding techniques. And you can do that at American River College. You can take like 2 to 3 courses and you could do most welding that for home remodeling, home improvement, landscape, and just basic stuff. You could do that. But when it comes to really doing it well, as an example, my company that I worked for had the opportunity to make weld prep equipment for Rocketdyne, who was making the exhaust manifold for the space shuttle at the time. And those things had to be so carefully made, and we could not induce any stress. So they do a weld, all robotic, and this was back in the 80s. The robot computer was, as big as my house to do this weld. But they were training people, and we made a lot of the training equipment, and we actually made the weld prep equipment for that manifold. It was 4-inch pipe. It was made out of something called duplex, which was high chromium nickel and stainless steel composite. The pipes were 4-inch diameter, and the thickness of the wall was 10 thousandths of an inch. And we had to prep it and hold it round within 1/2 of a thousandth of an inch. And we had to put a V on it that went 5 thousandths of an inch across the face at a 45-degree angle. So that was our weld prep. And we made this equipment that would do that on the shop floor for Rocketdyne. So you can imagine that training was incredible. But in general, you get somebody who is AWS certified in the process that you're using, and they're going to call it out. So we're going to look for training for AWS certified welders, and then the tests that are run to get the weld right. So you've done your work on the material, you've got a great welder working in place. How do you know it's done here? Let's see. Yeah, that was, so Eric says intense pressure. Yes, indeed. There was incredible, but it was worth it because I actually got to see a test fire of a space shuttle engine for Rocketdyne while I was down there. That I got to hold over for an extra 2 days, and they let me go watch it. Whoa. And actually, I felt it more than I watched it. Really, really freaking cool. One of the most amazing things that I've actually felt. And we were, 200 yards away, earmuffs on in this concrete bunker, and they fired that thing off, and we felt it shake everything. Really, really, really cool. I've had a chance to do some really fun stuff. Really, really fun stuff. Anyway, we'll also then, this is sort of like concrete, right? Like you're going to put up a big tower. You don't want it to pancake like that place that I worked on, Turnberry Plaza in Las Vegas. You don't want it to pancake. Just like this, you don't want a weld to break and have a bridge fail, like in the Hyatt in was that Kansas City Hyatt, or I don't remember if it was Oklahoma or Kansas City. The Hyatt walkway that failed because of a bad weld. Actually, it was a bad design. Actually, it was a good design. They got changed in the field with improper review, and it just wouldn't hold. It was one of the disasters. But you don't want a bad weld to have a problem. I worked on another job that was at a nuclear power plant, and they called us in to cut a piece of pipe. Literally, this was the most amazing. It was 16-inch. It was duplex again. 16-inch with a 4-inch wall thickness. So it had an 8-inch hole down the middle of it with 4 inches on either side in that pipe. And it was superheated steam from a jet pump riser. And it was welded pipe. And that weld seam broke. And it did the most amazing. It literally stretched that thing out about 200 or 300 feet, wrapped itself about 6 times around a column. And by the time it was done, I could actually walk inside the pipe. It had stretched so much. And that was because of a defective weld in the piece of pipe that they were using. On another one, oh my God, I'm not sure what happened to this guy. Another one, it was 32-inch pipe, about 8-inch wall thickness, and we did the weld prep on it. It was going between 2 portions of a nuclear power plant, and they did the weld prep, and the guy was lifting it up. It had to go up about 24 feet, get put into place, and then the welding equipment was going to start welding it. And it was going up. We had done the prep. It was all great. Our guys were getting ready to leave, and the crane operator dropped it and put a ding in it. And so they called us back, gave us another $30,000, and we re-weld prepped it. And the guy was picking it up, and he dropped it again. And I have no clue, but I do know this is actual, real, true, that plant And this was at Houston Light and Power. A different guy the third time, and you're gonna be horrified. But about 8 years later, they found a body in the concrete, and I'll bet you it was that guy. This is no joke, you guys. So you want to test to make sure that welds are right. Welds have to be right. They're bad. They're bad when they go wrong. And so there's tests for these things. So just because of the type of work I did, I know about those quite a bit. We're not going to get that into it, but it's kind of cool. So let's take a look. This is page 62 out of 676 of the A360-16 spec, and it talks about material. And it says, material and test reports made by the fabricator are sufficient evidence to conform that the shape has been made properly. So this is all about ASTM A36, different shapes. So as you do the different hot rolled structural shapes that we talked about, you'll see that there are some that have A36 as the primary material. Unidentified steel can be used only for members whose failure will not reduce the strength of the structure. In other words, things that are there just for the look. That's all. Or approval of the engineer of record. Who wants to be an engineer that stamps these things and is personally liable if something goes wrong? You do go to jail if something goes wrong. People have gone to jail. They do go to jail, and they should go to jail if by doing an improper approval, somebody is hurt. That's called being a professional engineer. That's why designers have it made. They're not held responsible. It's the engineer. Woohoo! Yay for designers. Cool. Now, for most of us, okay, we're not working in an area whose failure will reduce the strength of the structure. But if you start working for one of the structural steel companies or something like that around here, and you're doing steel construction, yeah, you got to make sure that you're using material that has been tested and certified to be right. So this is one of the places where you can go, and this is just a starting point. You should find 2 or 3 other sources to write your notes about how is A36 standardized and controlled. So now you can get essentially exactly the same material that has not been through the same control system, and you won't be able to use it for structural steel. You could even get the same steel that has been tested to a different standard for mechanical use in components and machining, and it could be perfectly fine and you've met all the requirements. Unless it's got that A36 stamp on it, you don't get to use it. Okay? This is one of the big places, and with my experience, I've got 2 types of experiences to put in on it, where you say, I want American-made steel. The reason that you want maybe American-made steel is that they will ensure through local agencies like Underwriter Laboratory, FM, Kleinfelder. There are other big testing agencies, and it's all locally stored data that you can look up any piece of steel and the bar and the lot number, and you can know that it's right. And of course, we consider that that's good for our economy, and we hire local jobs and all that kind of stuff. But for me, the main reason was this ability to get the certifications. Now, by the same token, I later on worked for a company that owned a manufacturing plant. It was one of those partnership things. We had to hire 600 Chinese workers for our 30 American workers to work at this steel foundry in Tingjingju, China. And we found that we hired about 150 engineers and their family. And their family members did all sorts of cool things. And these turned out to be very highly qualified engineers. Oh man, they knew so much, and they knew how to run every piece of equipment and run every test, and our quality was flipping amazing out of this foundry in China. So I've had and since we owned it, we had access to all the records. Now we also know that if you can't get the records, or the records aren't certified by a group that you trust, some group that has years of experience and certifies things, and you know that they're trustworthy, then you just don't get steel from there. So that's some information that you might want to look up and see as part of how is it standardized and controlled. You might look up who tests these things and ASTM standards and things like that. Okay, so then we want to take how is the workforce trained. So here's the AWS, American Welding Society. Tons of stuff on here. And look, they have certifications, they have seminar exams, they have facility accreditations, quick check verifications. That's if you're already certified and you just want an addition. So this is a group that you can go through and make sure that you are hiring somebody who's certified through this group, because they are very well known and have an amazingly good reputation. And they're what's called a consensus organization. So they're not run by a manufacturer, they're not run by a government agency, and they're not run by a sales force or an engineering group. They have members from all of those constituents or stakeholders, and those members get together on a regular basis. And and I was never a member of this one, but I've been members of other consensus organizations: National Fire Protection Agency Association, NFPA, National Backflow Association, American Society for Sanitary Engineering, mostly with respect to backflow prevention. But I happen to know that they're very, very careful. They listen to everybody. They're collegial. They work together. And their number one goal is public safety. It's not about making money for one group or the other. And granted, every group gets to give their input that there's no way we can afford to do this, or that's going to cost too much money to this group if you do it that way. That input is always there and it's welcomed, but it's never more important than anybody else's. And these groups are all for safety. So if you make sure that you require an AWS certified welder on your project, you're going to ensure that you have somebody who is well trained in a wide variety of spaces. And look, here's the next one: computer-based testing. How do you test somebody in COVID times and things like that when you can't actually watch them work? There's lots of cool computer-based testing, and there are a lot of computer-based welding operations. So here's an interesting page for you to look at that, and you don't have to copy everything, but you can really get into this and, benefits of certification and exam schedules and different what they call endorsements. So if you're trained in a standard and you're going to work for an aerospace company, you can get a little extra training or take a test and get what's called an endorsement that says you can work with aerospace. So, man, there's a lot of stuff here. This is one of the best training segments that you can look up, AWS. And then you can look at their welding certification program. A certified welder, an AWS certified welder means a lot. And you can even get certified in all these, all these different ways of welding. And look, all of these are on A36, 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 A37, okay. Position, that's really interesting. There's up, down, right, left, top, bottom. It's really, as you weld in a different position, you get a different type of weld. So as an example, Gale Manufacturing will only weld top position. Even if they have a 100-foot long beam that weighs 20 tons, they'll flip the beam to get the welder in the top position. And they do that for quality control. They know that their quality comes out higher with less rework when they do it that way. And they found that it makes them more money to avoid mistakes than to do rework. Okay, so they'll do I think it's 1G is top, but I'm not positive. I don't really know this stuff all that well anymore. But anyway, so there's all sorts of stuff in here that you can look at as you try to answer how is the welding workforce properly trained. And you should be getting pictures, too, of these things. Okay, and you can also contact our welding department. Just get a hold of somebody and or look at their webpage and go, wow, that's really cool. How that works. Okay, so there's another cool segment that you can look at. How is the workforce properly trained so that when you get a piece of structural steel on site, you know it's going to work. Now remember, when we put it together on site, you might do additional welding. You might be bolting it. You might be riveting it. So there's lots of ways that you could be also doing work on site, but we're talking more about what works at the factory. So the last part is what types of tests are run. We actually have a certification at American River College in non-destructive testing of welds. And you can imagine, you don't want to go most often, right? It's sort of like you have to cut it to see if it's going to work. Sort of like in concrete where we pour a whole bunch of extra little cylinders so that we can break them later on to see if the weld is strong enough. And sometimes you do that. As the weld gets going, you've got a batch of that steel and you have the filler material, and that welder has to actually make 10 or 15 welds following the processes that are involved, and they'll actually cut them up and look at them under a micrograph and see how they look. So that's one way to do it. But American River College actually talks about non-destructive testing. So one of the pieces of equipment that I got to design was called a weld crown remover. Because when you do a weld, there's usually a bump left over. And that bump makes it hard for ultrasonic testers to do a good test. And if you're doing nuclear power plants, as I said, you need to have a good test. So I actually made a piece of equipment that would track the pipe and slowly cut that crown off perfectly smooth so they could do non-destructive testing in nuclear power facilities. And it's very cool. My name is on a patent. I hold a patent for it. Of course, I don't own the patent. Tritool Inc. does. And we made about 20 of those. And then the nuclear power industry went bust in the United States. And we stopped making them. But non-destructive testing, ultrasound is one of the main ways, and there are other ways of doing it. So let's take a look and see how testing gets done. And so here's a cool site. It's by one of the manufacturers. So you can imagine that the manufacturers want to ensure that people do a really good job of testing so that their product isn't blamed for doing bad tests. So this is a little thing. So there's visual inspection. Okay. And it's very cost effective, but you have to look at this prior to, during, and after welding. You have to look at the weld preps and make sure that the joints are clean, smooth, the right shape, no rust, no nicks, to make sure that the right material. Okay. During welding, you have to look at the weld settings and you have to watch the process to make sure that there are no gaps that happen and that it's smooth and that the look is going right and that the gas is flowing all the time. And then after welding, you have to look at it and just sort of like looking at wood to see if there are any inclusions or bad spots. And you can even throw what they call Dicom on it or True Find and see whether things are there or not. Okay. For piping, you can also seal it and put it under water and put a little air into it and see if any air escapes. So it's a bubble test. And sometimes they do it instead of putting it under water because you can't so big. They'll spray soap on it. And because the soap bubbles a lot if the air comes through so you can really see. So there's a whole bunch of visual. And here's how you do it. Specs, during, watch the weld bead, beginning and end of each operation. So this tells you about it, but you would say that visual inspection is important. Radiographic, that's basically X-ray. And see this little bump right here is what we were talking about for ultrasound. For radiography, that's not that big of a deal. Okay? But that's kind of dangerous, right? There's some good and some bad about it. Not all radiation goes through all metals, density, thickness. And so you need more finely tuned, highly trained people to do radiography. And you can imagine, right, that radiation is not the most healthy thing ever. And so if you were to be the radiographer day in, day out, especially if you have to climb around on something that's hard to do. So you could be taking what they call too many zoomies and taking too much radiation. And in addition, of course, if you're trying to do a weld inspection, 50 or 60 feet up in the air on a place that it's hard to get to, that can be a problem. Which is one reason, by the way, why people like bolted joints, because you don't have to inspect. You just bolt those things together. You can do all your inspection of the joint ahead of time. Okay, but there's the weld crown that I was talking about. This is the weld area. This is one piece of metal. and another piece of metal, and they want to see all along this little joint that it actually looks like one piece of metal. If they see it looks like that, that's actually not right. It should look like it's one piece of metal. That's the idea behind a weld. Okay, the next one is magnetic particle. And of course, that works on some things, discontinuities in magnetic materials, and you're not always necessarily welding magnetic materials, but you can look at this and see liquid penetrance. Okay, so that's what we were talking about of different liquids will penetrate and leave different marks. Ultrasonic, okay, it's looking for that line, and if it sees that line, it doesn't like it. Okay, or if it doesn't have the right signature. All right, so there's tons and tons and tons of cool information about this, and you can even go to their site and look up some stuff about these, right? Just to get some extra good information about it. There's all about MIG welding, flux core, TIG, general pipe welding. That's where my life was. Codes, AWS, overhead. So anyway, that's a bunch of information about that. So that's really what I want to present. Let's take a look really quickly at what it says in the template. Because it may not be exactly that. Please go by that if you can. Okay, so this is a little bit more, it looks the same, but it doesn't have quite as much information. Lots of opportunities for images and whatever style you did that seemed to get good grades on your last 6.2, do that on your 7.2. Okay, any questions on the material? Okay, I can tell you all sorts of interesting weld stories. Lots of things went wrong in that job. I'm going to go ahead and turn off the recording really quick.